A histogram is always going to have two lines. Sometimes it'll stop at the corner here. This is always going to be the frequency. And frequency is the same thing as how often does that number occur. So frequency tells us how often something occurs. And along the bottom, we're always going to have numbers and things that we're going to call bins. And a bin is just going to be a little box on our graph. So when we had box graphs or bar graphs, they were little bars going across. When we have a histogram, they're all going to be numbers, and it's always going to be called a bin. And so sometimes they're going to say, like, what about with the bin width of 10? So that if they said, for example, we would like you to construct, so this time we're going to make it, a histogram with a bin width of 10 that represents this data. Super easy. What they mean by a bin width of 10 is that we're going to go from 0 to 10, 11 to 15, etc. So our numbers don't even start till we get to 57. So some poor soul might get a 57 on the first test. Sometimes you can write them all out like 0 to 10, 20, 30, 40, 50, etc. Sometimes they just kind of put like a little wrinkly line on the graph to indicate that there were numbers down there, but I'm not going to even bother with those bins because we don't have any numbers that fall in that range. So if we started here, we'd have 50, 60, 70, 80, 90, 100, 110, etc. No one's getting better than that because there's not that much score on the test. All we have to do, this is why histograms are super easy, is count up how many numbers fall in the 50s. In this case, only one number falls between 50 and 60. So frequency over here would be like 1, 2, how often it occurs. So since there's only one that falls in the 50s, our bin is only 1 high. How many numbers fall in the 60s? If we look across our list here, there's none in the first row. We got 2 in the second row, 1 in the fourth row. So we go up to 3. And our next bin would be 3 high. In the 70s, I have none in my first row, 2 in my second row, 1 in my last row. So that would be a 3 again, right? How tall would my bin in the 80s be?
6.
Let me say 6.
Yeah.
Maybe I can get 6 too. So we go up to 6. And my 80s bin would be 6. How about my 90s?
10.
I got 10 as well, and I chart only went up to 7, so let's add some. 8, 9, 10. And then how many in the hundreds?
1.
So we're back to one guy here. Sometimes when they draw their histograms, they'll even put the number of bins high it is. So like this is 1 high, we were 3, 3, 6, 10, and 1. And that way, especially if you're constructing it, if we're not sure how high that thing is up on the side, I can tell by looking at it. One thing that's really different about histograms versus bar graphs is that all of these bins fit exactly next to each other. There's no space between the bins because there's no space between, you get to 69, now you're to 70, you're in the next bin. There's no gaps. A bar graph like this one down here, where they said how many students had all the different colors of eyes maybe you could have. So we have 5 kids with blue eyes, we have 5 4-ish, 3-ish kids with green eyes, maybe 10 kids with brown eyes, a couple kids with hazel eyes. On the bottom of this graph, we're going to have categories, the color of eye categories. And on the side, we'd have how often it occurs. That's a bar graph. It still tells us good stuff, but it's not really a statistical representation. Versus a histogram, if you look at the histogram, remember on the bottom, we have only numbers. Not colors of eyes, but heights in this case, I believe. Yep. So how many students fall within certain heights in centimeters? And remember that we go up in however many digits we go up, it has to be incremental. So like on our one at the top, we went up by tens. And the one on the bottom, I went up by tens. I just started with, I think, I can't read it again, with the odd number, with 145. So 145, 155, 165, 175, 185. So all your boxes are the same width. So they're going to either be 10 or they can be 20, something like that.
And that little squiggly is important?
The little squiggly is just saying, look, there are a bunch of numbers before I get to 145, and I know that, but I am much too lazy to write them all down.
It's a good shortcut.
Here's my squiggle. Right. I'm not writing them all down. You could, and your graph would just be really expanded. So we can do a histogram also on our calculator. If you and we can do it by calculator. If I turn my calculator on and I go to my stat, let's see if I can get it out of the glare.
It's a little glary. Perfect.
If I get into my stat, I already put in those numbers for my test scores into list 1. So we go all the way down list 1. There's my 24 numbers, or how many I had. I can't remember now.
That's 24.
Good. If I wanted to make a box plot, I'd just turn the box plot on and I could graph it. And I could see a box plot of my data. Again, I could hit trace and I could go across and do the mean, the Q1, the minimum, the median, the Q2, or the Q3, excuse me, and the maximum. Or, and the two things that are important are, if you're going to make a histogram, you got to turn your box plot off. So since I had both things on, I'm going to turn this guy off.
Could you show us again what you need to do to get into that screen you just were at?
Yep, second y equals.
Second y equals. Thank
Yep.
you.
No problem. So second y equals, right now everything's turned off. And if I wanted to do a box plot, for the sake of being speedy here today, we would go down to a graph. You could do the first one still, just turn it off the box plot and turn it into a histogram. And you could say, okay, well I'm going to turn this guy on. And instead of doing the box plot here on the bottom, I'm going to go look at my other data options, and I'm going to pick the one that kind of looked like a bar graph, or in this case a histogram. And I can just hit graph again. And there's a good chance it's not going to like my window, but it did, so my day is happy. And again, we can trace it, and in this particular instance, because I didn't tell it how big to make its bin width, it's obviously picked something a little bit different, because the one we made by hand was a little bit different than the one that they had. So you can see that our bins are a little different than theirs. We picked a bin width of 10, and I didn't specify that on your calculator, but your calculator still made a representation. And this time, if you trace it across, it tells you that between two sets of numbers, so in this case, between 57 and 64, there were two numbers. Between 64 and 71, there were two numbers. Between 71 and 78.5, we didn't have any decimals, so that's interesting, there were two numbers. And so it just kind of tried to split them evenly between 78.5 and 85.5, between 85 and 92, between 92 and 100, and then between 100 and 101, we get that one kid who got their 100 on that test. So you can use your calculator also to calculate histograms. I think it's pretty easy to calculate them on our own, because all we have to do is count them up from our sheet that we started with. So we just took our data, we counted how many of them were in each of our bins, and we just made our bin that tall. So a couple of vocabulary things. The histogram is just this representation, like the box plot was its previous representation with the ends. A bin width is just how wide your bars are going to be. So they might ask you like a bin width of 10, a bin width of 20, etc. So that's how wide these bars are going to be at each of those times. Questions or thoughts about a histogram? Yes, ma'am.
Mine isn't showing up.
Your histogram's not?
Yeah.
Okay.
It's like saying error.
Yep. Try your Zoom 9 again. And sometimes you have to play with it for just a minute and then Zoom 9.